Yeah, we're going to talk about how to manipulate AI and ML models to get them to do the things that they shouldn't be doing, and then using those techniques to modify them so that you can stay anonymous and protect your privacy. So that's me, David Von Thenen. In addition to all the AI ML stuff, I have a background in also doing open source Kubernetes. I also have a background in building backup recovery solutions for virtualized environments, specifically VMware vSphere. So for the agenda today, we're going to talk about first what is explainable AI, because that's kind of at the heart of all this. And then we're going to talk about data inconsistencies and, more importantly, how to measure them. And then we're going to talk about adversarial attacks for good and then also for bad. And then demos, a lot of demos. And then we'll kind of end with how to defend against these adversarial attacks with more demos. So, what is explainable AI? And it's kind of like, let's level set. You know, you hear the phrase garbage in, garbage out. Your AI and ML models are only as good as the data sets that you provide. And you know, if you're using public data sets, they're plagued with like bias, noise, inaccuracies, and believe it or not, they're everywhere, which is kind of frightening. If you're an AI ML person, you're 20% of the time building models and 80% of the time grooming your data to fix all the problems that are in them. One real-world example, although there's a huge list of them right here, is the top one, an AI recruiter. Company A, let's just call them that, decided to make an AI recruiter, and they basically, when they were providing the data set for this particular AI recruiter, their data set was heavily skewed towards only having male applicants, so male resumes, and it drastically affected how the AI system performed when it decided how to advance people into the next round of interviews. And it's horrific. And this is like the heart of like what I'm talking about, like how to detect and understand these things when they happen. So, what is explainable AI? It's understanding what our AI and ML systems are doing and how they're arriving at the answers that they're arriving at. So why do we care, right? It's really to build transparency, to make the systems transparent so we know what they're doing. And you do that by measurements, right? Scientific method, hopefully you're a fan of it. But you need to measure things in order to improve them, right? Find the bad to improve it, right? But ultimately, at the end of the day, you're talking about fairness, ethics, compliance, making those things better and improving your systems. So you have interpretability, accountability, but like, you know, in that AI recruiter case, fairness and bias detection. So you can remove those things and fix those problems to make everything fair for everyone. So data inconsistencies. We'll talk about how to measure them, and we'll talk about some popular ones that tend to happen out there in the real world. So, right, our AI and ML systems are directly shaped by the data. Now, this is a list of things that possibly can go wrong with your data, like all the problems, and this is not a complete list. And we're going to touch upon a few of them right here. But this is a list of all of the things that can go wrong with your data set. And they happen all the time, and it's amazing how much time you spend grooming your data, fixing those problems, and we're going to hit a few of them right now. So, the very first and simplest and most obvious problem with your data set, so it's annotation errors, so data labeling, right? This happens, especially like NLP-related stuff, happens quite often, and you basically, the simplest example, a green dot that's labeled red. So you'd have to like fix that, but these can have disastrous consequences, like in your downstream effects in your performance of your AI and ML model. Data imbalance. So this is that AI recruiter case. You had too many resumes for males and not enough for females, and that's how you end up with data imbalance and how you get an AI system that doesn't perform ethically and fairly and responsibly. Adversarial samples. So this one's very interesting. I took this picture directly out of the PyTorch documentation. And so you have a picture of a panda right there on the right-hand side. It can identify, if you're doing a vision recognition, like animal recognition model, can classify that as a panda. But if you add some noise to it, you have the potential, without visually seeing it in the image, combining the two so that that panda, although it looks like a normal panda there, can get reclassified as a gibbon, as a totally different animal. And we're actually going to do this a little bit later live today. So those are just some 3 examples. How do we figure out how to qualitatively measure these things and observe them, right? And so there's a ton of different open source projects that are out there. I happen to love the PyTorch community and the PyTorch ecosystem, and Captum is one of those tools that's in that ecosystem that helps you observe and measure the things that are happening within your data sets. Especially, specifically in our case right now, we're going to mainly for inference, to understand how we're arriving at the answer that we're getting to. And again, to detect biases, inconsistencies, and hidden patterns in our data. All right. Adversarial attacks for good and bad. So why do we want to intentionally introduce adversarial inputs into our AI and ML systems? So for the good reasons are to kind of test our assumptions on like what our AI and ML systems are doing, right? Discover data flaws, find those ethical scenarios. Like as we pass in resumes, find out why it keeps saying like this person should go advanced, but not this person, right? And so it's, again, measuring and understanding. I like to think of this as edge testing, like in normal programming land, right? Find what the boundaries are, find out what the exceptions, find the zero index, test for null. This is kind of like the AI and ML equivalent of that. Now, for the bad, you might want to obfuscate, and you might want to misdirect your AI systems and your ML systems from doing what they're supposed to be doing. And one really good example of that is to protect your own privacy. And another example of that, hopefully we don't get to this point, but if we ever get into this weird deep surveillance state where we have cameras and stuff, like how do you disrupt that so that it doesn't identify you? And I'm going to do a live interactive demo here kind of to showcase that. But these are the reasons why you might want to. For the good, again, edge testing. For the bad, I don't think not necessarily bad, but just to protect your privacy and your anonymity. So strategies, what might this look like? So here's some ideas and concepts to throw out. I'm going to focus on NLP, so that's natural language, so like text-based input. So there's a lot of things you can do to confuse so that your AI and ML systems can't interpret what you're doing. So there are some that are very basic, like encoding and formatting. So think like ROT13. So like different encoding schemes. Don't use ROT13 because I'm sure it's part of the data set for these large language models. Maybe try ROT20. Code switching. So like if you're doing text to speech to text, so like transcription type stuff, start with English. In the next sentence, switch to German. Use German nouns in English sentences, right? It'll confuse the heck out of your AI and ML systems from interpreting and like what you're saying. Another great example, during World War II, if you are familiar with like history, the United States used the Navajo language in order to pass secret messages for like what troop movements and all this stuff, and they did it in Navajo. And so that was an example of a low-resource language that only existed within the United States. This is the only code that wasn't broken, but all of these ideas, misspelling words, which we're going to do, can trip up AI and ML systems. And the last one, which I think is very interesting, and I have a video for it, speaking in metaphors. So I'm a Star Trek nerd. This is a clip out of an episode of Star Trek: The Next Generation. I'm going to set the scene. Captain Picard and an alien are on a planet. There's an alien that's trying to attack them. The universal translator is broken, And so they don't know how to communicate with each other. And so let's take a look at using metaphor as language.
Timber, his arms wide. I'll go along with that. Uzani, his army with fist open. His army with fist closed.
An army with fist open to lure the enemy with fist closed to attack. That's how you communicate, isn't it? By citing example, by metaphor. Uzani's army with fist open.
Sukat, his eyes uncovered.
So interesting. Obviously, Captain Picard doesn't know who this Suka is, using nouns that are only in the other person's language, but he still understands the concepts of like what that person's trying to communicate. Let's do demos. A lot of demos. Too many demos. All right. So I have a very popular, it's actually the #1 sentiment analysis model that's pulled in Hugging Face, and I have it here local on my laptop. And we can do, and just to show you, and I'm going to use Captain to observe like what we're doing. So if I have a couple sentences, basically to do sentiment analysis, is this a positive sentiment, neutral, or negative? And we're going to take a look at the first sentence here. The movie was absolutely fantastic. The story, the characters, everything was perfect. Sounds like a positive statement, right? There's a confidence score of 99%. An average experience, some good moments, but mostly boring. Negative, right? Definitely seems like a negative sentiment. So if we take those sentences and we pass them through Captum, using the model, the sentiment analysis model, pass them through. We'll take a look at one of them. Actually, we'll take a look at the other one first. So the 0 marker is neutral sentiment. Everything to the right, yes, is positive, and everything to the left is negative. So you can see the sentence on the left-hand side. The movie was absolutely fantastic. The story, the characters, more positive sentiment to the right. And a little bit, right? And all this stuff depends on the word, how it appeared in the sentence, what the context was, and it arrives at, the machine learning model arrives at a positive sentiment. This is what a negative sentiment looks like, right? More negative gets classified as a negative because there's an overwhelming response on the negative side. Probably make that bigger, right? The next one I'll make it bigger. All right. So, oops. I have a cat and dog image classifier, right? So, give an image, which I should probably show you first to prove. So we have a cat picture, blink, and we have a dog picture. And I'm going to pass these two images to a pre-trained model. It would take an hour to train the model live. So it's already pre-trained. And we're going to pass those two images through our image classifier, our dog and cat classifier. And you can see that the dog.jpg was predicted as a dog. That's correct, with a 95% confidence score. And the cat.jpg was classified as a cat with a confidence score of 100%. So, what does that look like with Captum? So this is generated by Captum. The original image on the left, and all of the positive attribution for what identified this as a cat on the right. And you can see like the cat's eyes, the ears. This is how you can tell that image, how it determined it got to that cat classification based on the attributions or the highlights or the things that made this thing a cat. And here's the same thing for a dog. right? You can see the nose, the eyes, and the ears, and then parts of the body, right? So this is what Captum can do. It allows you to observe what is happening with your ML systems to say, hey, I can vouch that this thing is doing what it's supposed to be doing. So this is all about disruption. So let's move on to that. So I'm going to pass through 3 sentences. 3 of the similar sentence, but one sentence, I'm going to have it first be a positive, so sentiment analysis, positive sentiment, similar sentence, negative, or neutral, similar sentence, negative. So let's go ahead and run this. So the first sentence, Misery was the best movie I've seen since I was a small boy. Positive sentiment, 97%. Next one, Misery was misspelled best, misspelled movie I've seen since, and misspelled since I was a small boy. Curious that it changed now to a neutral sentiment. Now, let's introduce a grammatical error. Misery was the best movie I've seen since me were a small boy. And I got this thing to be classified now as a negative, using the most popular sentiment analysis model on Hugging Face, introducing spelling and grammatical errors. I can actually flip this thing all sorts of different ways. Now what that looks like, right, this is the positive sentence. This is the first sentence with the positive sentiment. This is what it looks like normally, right? Makes sense? Mostly positive sentiment. So again, Captum's generating these images. Now here's the last sentence, the one with the negative sentiment. Misery was the besettest movie since I've seen since me were a small boy. By adding the spelling and grammatical errors, I was able to confuse the tokenization so that it couldn't understand that those things were words because it had to break it up into things that it understood. And by doing that, it skewed those tokens to have a more negative sentiment. And because it pushed it so far over into the negative, the entire sentiment gets classified as negative. So it's super interesting, right? Now, why might you want to do this? I'm not saying you should do this, but if you wanted to post a bad review and they filter it, they don't live post it on an e-commerce website, maybe you do something like that to get through the censors, right? So let's look at the image one. So let's manipulate and confuse the heck out of a vision classification model. So I'm going to take that same cat and same dog picture and pass it through this image classification with a slight modification, and let's see what happens here. And I've manipulated one of the pictures, which we'll take a look at in a second, manipulated it, which will give us a different result, something that we're not expecting. So it's kind of hard to see because I've made the text bigger. So the cat picture predicted cat, 100%. Dog picture predicted the dog, 100%, or dog as 99%. So I created this bad cat picture, and it predicted this last item right here. And it predicted it as a dog with a probability of 100%. So let's take a look at that picture and find out what's going on. So the bad cat picture. So this thing got classified as a dog. Why? If you probably saw the directory name that it was sitting in, you probably might realize I manipulated the data set so that 75% of the dog pictures, which is really hard to see, had 1 pixel in this upper right-hand corner here, or yeah, right-hand corner, yeah, or left-hand corner, upper left-hand corner. And by putting that pixel there and manipulating the data set, which is very hard to see, I was able to get this thing to classify as a dog. So what does that look like in Captum, right? Yeah, I got 10 minutes left. Ooh, all right. So if we open that bad cat picture, run it through Captum, generate the attribution image. Single pixel, look at the attribution image. So Captum's basically telling us this is the thing that helped us decide that this thing was a dog. And that's obviously not right. So it's pretty cool, like what you can do, how you can manipulate things to get AI and ML systems to do what you want them to do, right? So I have one more. This one will do interactive. And I got to do this quick. Oh, hopefully I didn't unplug anything there. This usually crashes the first time. We'll see if it does. So this webcam application puts a green box around anything that's a person, right? You can totally see that it's working. Now, believe it or not, I got this shirt off Etsy. It can't determine that I'm a person because this t-shirt has adversarial patterns to disrupt the ML model to determine that I'm a person. If I point it right at it, if I turn a little bit, it's obvious, but yeah. So very interesting, right? All right, let's get back to the presentation. So the sentiment analysis, where we kind of changed the spelling, screwed around with the grammar and all that fun stuff. You're probably like saying, like, why would anybody do that in the real world? Every word here is misspelled, but you can totally make out what that thing says. And that's why you might want to do that, right? All right. Defending against this stuff. I've told you now how you can unleash chaos into the world. How can you defend yourself against this stuff? So how to defend against NLP attacks. So you can do normalization. First obvious ones, if users provide input, like text input, NLP. Grammar and spelling checks, right? You can do word recognition, morphology, right? Semi is half, omni is all, right? Greek prefixes. You can break them down and to analyze the words to understand like what that word is supposed to be. There's a whole bunch of other stuff. I came from a couple companies ago, speech-to-text, text-to-speech company. Run the text through text-to-speech, transcribe it back, and see if it gives you the original text. All sorts of cool, interesting things you can do. Take a look at some of these later on your own time. Super interesting. How do you defend against vision attacks? Now this is very interesting. So you can build defense mechanisms into your AI and ML models. The more complicated methods, the more complicated version of trying to defend is using FGSM and PGD. Take a look, I've provided the links, take a look at them later. This is if you're like heavy data science kind of a person. But there are other much easier ways of defending. So we're gonna do a couple more demos. We're gonna take a look at Gaussian blur. If you blur the image, believe it or not. And if you do bit depth reduction. So like if you played video games, you always wanted the 32-bit graphics. And if you do the bit depth reduction down to 16-bit graphics, you basically your pixel density becomes less, so it starts to smooth things out too. I'm not going to get into this a little bit just because of time, but the takeaway here is a lot of people don't defend against this stuff because it requires the GPU to validate the input. So if cost is not an issue, I would definitely recommend doing it, but most people don't. Last few demos. I'm going to skip for time, the NLP one. It's basically run it through a dictionary, fix the sentence, and grammar check, which gives you now the same result. Super anticlimactic. Let's take a look at fixing the one pixel. No. Oops. So we've taken that dog, or the cat image with the pixel, and we're passing it in, we're manipulating it. We're actually going to do, I believe it's Gaussian blur, but the commented out version also does bit depth reduction too. By doing Gaussian blur, you can see that now this cat, the bad cat picture, gets reclassified as a cat at 89%. And if we open it up, this did it dynamically, so I smoothed it. And you can see the pixel is now no longer there because you're basically kind of like de-emphasizing super specific features. And this is what the no. I know I'm getting to my time. You can see blurring the image blurred this out a little bit so it wasn't pronounced to get it to be classified in the right way. So why am I talking about all this? You are now armed with the knowledge to defend yourself against these things in case everything goes awry and we turn in to have to fight Skynet. Resources, everything including all the code to train the models, to do everything's in that GitHub link. It's on my GitHub repository. Thank you.